want to maintain this question, look at how do we find the steady state values of capital per effective worker, output per effective worker, and then growth rate of output, output per worker, and output per effective worker. So we'll start with finding the actual amount of investment per effective worker in the economy. So we want to find for actual investment per effective worker. The amount of effective workers are your A times your N, right, which is number of workers in the economy, right? So over here, let's first start with what do we know investment is. Under the assumption that it's a closed economy and government spending is equal to taxes, we know investments are equal to savings, right? So it's under the assumption of Solow model where you're assuming it's a closed economy and G is equal to T, right? So investment is equal to private savings. And then further an assumption the Solow model makes is this, that these private savings are equal to saving rate times your output income file. So now because we're interested in investment per effective worker, so let's dividing both sides. So this I is equal to S is equal to small s y we've written based on the assumptions made in the Solow model. Now to get it in per effective worker terms, dividing both sides by AN. So then this becomes I by AN. So I'm just dividing both sides of this by AN. So this becomes I by AN is equal to S, and then I can write this as Y by AN. Right, we can write it like this. Now let's just let let's just do some notational thing and let I by N be I tilde, so it's investment per effective worker, and Y by AN be equal to Y tilde, it's output per effective worker. So I can write this as I tilde is equal to S Y tilde. So this is just notational stuff. Now replace Y tilde is equal to K tilde 1 by 2 per effective worker production function, right? This is investment per effective worker in terms of Y tilde, but if you notice the question says to get it in terms of K tilde. So to do that, what we will do is we'll replace Y tilde is K tilde power 1 by 2, this per effective worker production function given to us. So per effective worker production function, right? So it's per effective worker production function. So we'll replace Y tilde is equal to this to get I tilde in terms of K tilde, right? Because over here we have investment per effective worker in terms of output per effective worker, but the question says we want it in terms of capital per effective worker. So we'll use the per effective worker production function given to get I tilde in terms of K tilde. Then this would be I tilde is equal to S K tilde power 1 by 2. Now, we're told since S is 16%, it's given to us, since we're given that the savings rate is 16%, it's given over here, S is equal to 16%, right? So we can write investment per effective worker is 0.16 times capital per effective worker power 1 by 2. So in this way, we can write our actual investment per effective worker in terms of capital per effective worker. So get the next part. So the next part asks us to find the break-even level of investment per effective worker that is required to keep capital per effective worker constant now in the face of depreciation, population growth, and technological progress. So I want to find I tilde break-even. Now in this model, this is going to be delta to account for depreciation, GA to account for technological progress, and GN to account for population or labor growth times K tilde. Like in our very first, the basic Solow model, where we did not have population growth and technological progress, break-even investment was only needed to account for depreciation. Once we added population growth, then we needed to account for GN. And once we added technological progress, we need to account for GA as well, right? So now we're told that since delta is 0.1, the depreciation rate is given as 10%. It's given over here equal to 10%. And GA, technological progress, is given to us as 0.04. It's given over here. Sorry, let me just do it a little lighter. This, right? And we're given, and GN is equal to 0.02. And GN is equal to 2%, right? So then you can write I tilde break-even level of investment per effective worker as 0.1 plus 0.04 plus 0.02 times K tilde. So this is basically going to be 0.16 K tilde. So this is all for this. This is how we can find actual investment per effective worker and break-even level of investment per effective worker. So next one asks us to find the steady state values of first capital per effective worker. So this was supposed to be part C. So part C, right? One. So we want to find K star tilde, right? Steady state value of capital per effective worker. How will we do that? Now, one difference of the Solow model with technological progress from the basic Solow model, where you did not have technological progress or population growth, or the Solow model where you only had population growth but no technological progress, is that in the first two versions of the Solow model without technological progress, all of our analysis is done in per worker terms. But in the Solow model, where once you introduce technological progress, then we're going to do our analysis in terms of per effective worker terms. And here's a sort of technological progress we're talking about is labor augmenting, where it increases efficiency of your labor, right? That's why in this case now the all the analysis that we do once we have this labor augmenting technological progress is in per effective worker terms. Now for steady state value of capital per effective worker. So without technological progress in steady state output per worker and capital per worker are constant. But once you have technological progress, then what is constant? The output per effective worker and capital per effective worker in the steady state. So now in the steady state, with labor augmenting technological progress, what is constant in steady state is not output per worker and capital per worker, it's output per effective worker and capital per effective worker. So in steady state, K tilde is constant, capital per effective worker is constant. If it's constant, this means change in capital per effective worker, which is investment per effective worker minus break-even investment per effective worker is equal to zero. So this means that investment per effective worker is equal to break-even investment per effective worker, right? So this is what this means. So what we can write is we can say that 0.16 k tilde 1 by 2 is equal to 0.16 k tilde. What are these? This is, if you recall, I tilde from part A, right? This is the investment so this is the investment per effective worker we found in part A, and this is the break even investment per effective worker we found in part B, right? So this is this, right? And then from here, what we can do is if we simplify this a bit, so this just then becomes, if you simplify this, 0.16 by 0.16 is equal to 1 is equal to k tilde power 1 by 2. So then this just becomes k tilde star is equal to 1. So steady state value of capital per effective worker is 1. Now let's do the same for steady state value of output per effective worker. So the second part is we want to find what y tilde star is, right? So what we'll do is for this, we'll just plugging in k tilde stars, steady state value of capital per effective worker in per effective worker production function, right? In per effective worker production function, which is given to us as y tilde is equal to k tilde 1 by 2, it's given over here, right? Right, so then this just becomes कि y tilde star is equal to k tilde star power 1 by 2. So then this is just 1 power 1 by 2 is just equal to 1. So the steady state level of capital per effective worker and output per effective worker is 1. Now let's do part 3. Part 3 says we want to find the growth rate of output per effective worker, right? So growth rate of output per, sorry, my bad. Growth rate of output per effective worker now, right? So we want to find this now. Right now, for this, what we need to keep in mind is once you have labor augmenting technological progress, so in steady state, y tilde is constant, output per effective worker is constant, right? That's how we define the steady state with labor augmenting technological progress. The capital per effective worker and output per effective worker are constant. All of our analysis is in per effective worker terms now. So this means growth rate of y tilde, which is gy tilde, is equal to 0 in steady state, right? When we did not have technological progress, then in the steady state, output per worker was constant. So its growth rate was 0 in the steady state. But now, since once we introduce our technological progress, our analysis is in per effective worker terms. So what is constant in the steady state is output per effective worker. So its growth rate is 0. Right? And then if we do the next part, so there we want to find, right? So, so in the next part, we want to look at output per, okay, so we want to look at output. Okay, so let's do for growth rate of output. Okay, for G star Y, Now, so let's do for G star Y over here. So we want to find growth rate of output in steady state. So now we know how we define Y tilde was Y by En. So from here I can solve for Y, right? Y over here is just Y tilde En. So I can make Y the subject over here because I want to find the growth rate of output. Now in steady state, right, in steady state, y star would be equal to y tilde star. So I'll just plug in the steady state value of output per effective worker. So I'll get the steady state value of output per worker, right? So from here, we can see the growth rate of y star would be just equal to the growth rate of y tilde star plus growth rate of A plus growth rate of N. Now, why is that the case? This is because if you recall that if z is equal to, this is again one of the properties of growth rates, that if z is a product of x and y, then the growth rate of z is just the sum of growth rate of x plus growth rate of y. Since y star is just a product of y tilde star and, so the growth rate of y star is just the sum of the growth rates. It's one of the properties of growth rates, right? And we know in the steady state this is equal to 0. We just saw growth rate of A is given to us as 4%, growth rate of N is 2%, so this is 6% growth rate of output in steady state. The last thing we want to look at is the growth rate of output per worker in steady state. Without technological progress, we know that used to be 0, because in that case, in the steady state, output per worker was constant. Now, output per worker is not constant, but rather what is constant now is basically, what is constant now is capital per effective worker and output per effective worker, right? So now we want to find growth rate of output per worker. Just keep in mind notation over here. Capital Y is output, small y is output per worker, and y tilde is output per effective worker, right? So just some notation bits over here. Output per effective worker, right? So here I want to find growth rate of output per worker, right? So over here, now we know for this, let's again recall how do we define y tilde? It's y by en. First, we're interested in y. Now I want to find what output per worker is so that I can find its growth rate, right? Initially, we wanted to see what y is. So now I'll solve for yn. So this means y by n is equal to y tilde times a. And this is what? This is output per worker by small y, right? And this is output per worker, which is small y, right? And I want to find its growth rate. So now the idea is that now we know in steady state. So now from here in steady state we know. So y small star would be just y tilde star times a. Obviously, I'll just plug in the steady state value of output per effective worker to get the steady state value of output per worker, right? And then we know the growth rate of y star would just be the growth of y tilde star plus growth rate of a, because we just talked about, and this, where does this come from? We just talked about this. Recall, if z is equal to xy, then if a variable is a product of two variables, then its growth rate is the sum of their growth rates. We just applied this to find the growth rate of output as well. Like this we know is 0 in steady state. Growth rate of output per effective worker, this we know is 4%. So the growth rate of output per worker in steady state is 4% greater than 0. So the idea is that once technological progress is incorporated in the Solow model, we can explain sustained growth in output per worker and persistently rising living standards, right? Because without technological progress, the growth rate whenever we found of output per worker was 0, because in the steady state output per worker was constant. Once you have this technological progress, then you can have sustained growth in output per worker.